In this video, we're going to take an overview look at Room Database and how we can integrate it with live data in Android and Kotlin. I'll discuss this in the context of a class diagram that we put together in an earlier video. First of all, we're going to have a database class here, which extends from a class called Room Database. Then we're also going to have an interface, which represents a DAO, and we're going to have a DTO, which represents an entity. In Kotlin, we often call DTOs data classes. So first of all, why do we want to use Room Database and live data? Right now, we have an autocomplete text view on our fragment, and we're populating the list that's used to autocomplete from a live JSON source, which means each time we start the application or each time we load that screen, we have to go out and make a network call and get this data. Now, per iOS design guidelines, if we have an autocomplete, we should really use local data as the source of data for that autocomplete. We shouldn't make a network call each time because naturally that's inefficient. So in this video series, we're going to add a new component, which is a Room Database, which lives on the device itself. It's kind of a wrapper around SQLite, and I'll tell you, the old days of SQLite where we would write database calls manually and write our tables manually, it was a bit of a pain. Room Database makes it really easy to do this. So the other nice thing about Room is that we can use live data on it, which means that we can observe what's going on in that Room Database, just like we're observing our retrofit client instance, which is parsing the JSON data source. So what we'll do is we will take our data and we'll put it into the Room Database, and then we will allow our UI to observe on that and receive updates from this Room Database so it doesn't have to make a network connection. As a matter of fact, that helps us to have our application work offline. So a few things about Room. Current version is 2.0. It has really good frameworks for testability as well. We talked about how it supports live data. We will look at a hands-on example of that in a future video. This is just an overview video. Also raw queries, we can do SQL queries against it. Now the other features I have here are Xjava, JavaUtil optional, and Guava. Those are other things that work with Room, although I'm not going to do a hands-on example for those. So one nice thing about Room is that we can use a lot of the concepts that we already understand. So we know in Java we have something called a DTO, or a data transfer object, and in the land of Kotlin we call that a data class. We can use a plain old data class and we can associate it with a table just by using these annotations. So we start with @entity on the top and then we give it a table name. We pick one of the attributes and we make it a primary key. Now, it will typically use the attribute names to create table columns in the database. But if for some reason we want to create a column with a different name, we can simply use this @columninfo annotation and describe the name that we want to use instead of the attribute. Here's an example of a DTO that I have decorated with some of these attributes. So data class plant, and you see that we have the @entity attribute, and we're associating this with a table named plant. Remember that, we'll come back to that in a little bit. Additionally, I added the @primary key annotation before this plant ID field. Really, that's the only change we need to make to the DTO. Now the DAO, we're going to make a new DAO for this as well, and this is an interesting one because the DAO is just an interface, and we give it certain annotations as well. So on the top of the interface, we put @DAO. On the top of a fetch method or a get method, we'll give it an @query, and we'll typically give it a SQL-like syntax there. Now there's also something else called raw query, which is not checked at compile time. We won't do an example of that, but we will do an example of @query. @insert, we'll put above an insert method, and then @delete above a delete method. So once again, let's take a look at a DAO example. I mentioned it's an interface. Now remember what an interface is. Similar concept in Java and in Kotlin. An interface is just a list of methods, and that's an important concept. We don't actually have to create a concrete class that implements this interface. In other words, we don't have to give behavior to the methods. All we have to do is define what the methods are, or in Kotlin, as we call them, functions, and we have to give the proper annotations above the functions, and then Kotlin will figure out what a concrete class should look like that implements these interface functions. It's really very straightforward. This is all there is to it. Now take a look at this insert annotation. You'll notice there's a property defined here called onConflict. Now that's optional, but it's a good idea to specify that. And you see I have here on conflict strategy replace. There are a couple of options that we can use there. We can use replace, ignore, or abort in this case. What that means is, let's say I'm inserting a row into the database, and there's a primary key for this row that matches an existing row that's already in the database. In other words, I'm trying to insert a new primary key where that same primary key already exists. Do I want to replace the record that's already there? Do I want to ignore my change, or do I just want to abort the whole thing and say, gosh, I don't know what to do here, so let's go ahead and stop? That's what that on-conflict strategy is for. When I first did a rehearsal for this presentation, I didn't include on-conflict strategy in my demo I was putting together, and I noticed I kept getting exceptions because it kept trying to insert rows where a primary key for that row already existed in the database. So I changed mine to on-conflict strategy replace, and the exceptions went away. One more class we're going to need is kind of like a bootstrap class called Room Database, and this connects our DAO and DTO together with the whole concept of the Room Database. So for this, we need to extend with an abstract class. Now, what's an abstract class? An abstract class is something between a class and an interface. It means that we have behavior in there, but we also have some functions that are to be defined. And we're assuming that we are going to be subclassed one more time, at least one more time. And the subclass of us will provide some definition to those functions. So all we need to do is make this abstract class. Room will take care of everything else for us. Here's a look at an example Room Database class. So you see that we are extending from a class called Room Database. We're extending this with a subclass where we have defined a name. In my case, I've called it Plant Database. But note, I've also given it this abstract modifier here, which means that this class may have functions that kind of are like an interface where we've just defined the signature. We've not defined the concrete implementation. And indeed, that's what we have. I have defined a function of my own making here, abstract function local plant DAO, and what's it going to return? We'll take a look at that. It's going to return, let's control click here, and we'll see it's going to return that DAO that we just looked at just a moment ago. Back now to our Room Database class, and you see it also has this @database annotation on top of the class, and we have an entities attribute here, and then you see array of, and then you see something called plant.class here. What's plant.class? Control click into that, and this looks familiar as well, right? It's our data class or our DTO that we've defined before. Now let's put it all together. We have our data class or our DTO here. We have our DAO interface here, and we have our kind of bootstrap Room Database class here. Remember, the data class has this @entity annotation, and it has a table name equals plant. Now what happens to that table name? Well, that's the table name that we use in the @query annotation in the iPlant DAO above our getAllPlants function. So that's how our DTO and our DAO are linked together. Now you notice our data class name is plant, and what happens to that data class name? Well, remember, that goes up to the @database annotation that's above our little Room Database class here. So that's how our database class is matched up with our DTO. Coroutines work well with Room because queries are synchronous. So in other words, they're blocking. When you're running a query, if it's an insert or an update or delete or select or whatever it is, it's going to block the thread that it's on until it returns. So for that reason, it's a good idea to match together coroutines and Room. And in some videos prior to this, I gave an overview of what Kotlin coroutines are, and then a hands-on demo that's going to get us set up nicely to implement our Room database. That's an overview look at Room. In our next video, we'll do a live implementation hands-on. I hope this video has been helpful, and I look forward to reading your comments. Thank you.